So this transformations lesson is over rotations, and rotations have a t sound in them, which helps us to remember turn. So it makes sense. We've heard the word rotation before. Imagine something rotating, like a tire rotates, something turns, and that helps us remember. So one thing that turns are the hands on a clock, and it's helpful to think about clocks when you're thinking about rotations because we talk a lot about clockwise and counterclockwise. So a lot of us in the digital age are not quite used to remembering what it was like to look at a clock when we have to think about what's clockwise and what's counterclockwise. But if you can remember what the direction the numbers are in, obviously we start at the 12, right? But we go this direction. This is clockwise. It's going to the right. If you want to think about it another way, most people are right-handed. So we're going to kind of go the common way. People are right-handed. And I'm going to point out clockwise because I generally want you to think about what's clockwise, because we could always name something counterclockwise compared to clockwise. And I'll show you what I mean in just a second here. But just remember, clockwise goes to the right. So when we are rotating, we're going to talk about how we make turns so that we can know which direction to move our point on our coordinate plane or our shape. So if I have a starting point, in this case I put a starting point here, I've kept it simple, 0.15, and if I said, hey, take that point, okay, and you can imagine maybe it's a point and it's a part of a bigger picture, but if you take that point and you want to move it clockwise, you don't know exactly how far you want to move it, so the directions will typically say, move it 90 degrees clockwise, or 180 degrees, or 270 degrees, and those are basically quarter turns, half turns, 3/4 turns. So imagine yourself, if I move a quarter turn one direction, that's the same thing as if I had the same starting point and I moved 1, 2, 3 turns the other direction. So if you're looking at this example here that I have on the paper, if my starting point is here and I'm going to do a 90-degree clockwise turn, that is the same finish line or ending point as if I had the same starting point and I did 1 turn, 2 quarter turns, 3 quarter turns. So they ended up the same. So 90 degrees clockwise is the same thing as 270 degrees counterclockwise. So going where all the lefties are going, right? And so for a lot of transformations, rely on visuals. I think they help me. I think they help a lot of students. But for transformations involving rotations, I rely heavily, for me, on some shortcuts. So a shortcut is, no matter what your ordered pair is as you go through, if you're going to go 90 degrees clockwise, and just think clockwise, which is the same thing as 270 degrees counterclockwise, basically what you're going to do at that point is your Y is going to be the first number listed, and then it's going to be your X, but don't forget to switch your sign, okay? So whatever your X was, it's going to be moved to second place, right? And then changing the sign. So if it was a negative, it's going to be a positive. And then your Y is going to be the first number. So for example, if I have 0.15, it is now going to be 0.5 negative 1. So it feels a little bit tricky right here at this point, but if you try to start moving shapes without being sure, knowing where the coordinates are is much better. Okay. So I also want to explain, okay, we also have the same idea, the same point here. If we have 0.15, I need to scooch down a little bit more. If we have 0.15, and I say, okay, take that point. I want you to do 2 clockwise quarter turns, or in other words, 180 degrees, so like basically a full turn. If I'm looking at you, and then if I do 1 quarter turn, and then another one, you'll just see the back of my head. So we don't want that. We want you to face forward, hopefully, and to keep on explaining that that's the same thing as 180 degrees counterclockwise. Same starting point, but if I'm moving to the left and going counterclockwise, I'm going to have the same finish point. So the trick on this one right here is, again, 180 degrees clockwise and counterclockwise. It's going to be the same for both of them. If we have a starting point that's X, Y, all you're doing is changing the signs of those numbers in your point. Okay, so if I had 0.15, like I did already, now I'm going to have it landing at -1, -5. So you can imagine, it might be tempting to think you have to put your dot right here, your point right here, 1, 5, and then 1, -5, but it's -1, -5. Got to change the signs on both of them, because if you really turn it the way you're supposed to, it would end up there. And finally, the last kind of explanation before we move into some examples is if I'm going to go 90 degrees counterclockwise or 270 degrees clockwise, that's the same thing again. It's kind of like we talked about this turn on the right earlier, and now we're just kind of landing in a different place. So I like to always kind of keep it base out of think clockwise because that's where our clocks are moving, and that's easier for students. So 270 degrees clockwise is the same thing as 90 degrees counterclockwise. And the trick is with that one, X then Y is going to become, your Y is going to be first. Now this time we change the sign of our Y, and then we have our whatever our X number was for our coordinate point. So if I have 0.15, I'm going to flip them. I'm going to switch my 1 and my 5, and I'm going to change the sign of that first number. So 1.5 became -5.1. So that's not something I'm expecting you to memorize right away, but it's definitely going to help you make sure that you understand how to rotate properly. So in the next video or two, I will do some examples.